Every week I choose the picture of the week, which appears on the BAA website. The interesting thing for me is that 70 years ago, telescopes 200 inches in diameter were taking pictures of the sky, the Hale telescope in California, for instance. Today, we're getting people sending pictures of the week candidates in, which are at least as good as was produced by that telescope.
Well, the object in the sky that really interests me is the moon, and that's really because it's the ideal object for astronomical observation. It's easy to find, it's visible throughout the year, you don't need elaborate go-to systems or star charts in order to locate it, it's a decent size, no possibility of confusing it with anything else. And even with the naked eye, you can actually see detail on the lunar surface. You've got those dark and light areas that form the familiar pattern of the man in the moon. If you've got binoculars, then you'll immediately see that you can make a distinction between the bright terrain, which is highland terrain, absolutely scattered with craters, and the darker areas, which were regarded by the ancients as being seas, and in fact were called seas, are not seas at all, but they're vast lava plains. If you can get a small telescope, then they will reveal literally thousands of those craters dotted all over the lunar surface. And there's enough detail there really to keep you occupied for the rest of your life.
There have been three wow moments for me in astronomy. The first time I saw a large sunspot, seeing my first solar prominence, and witnessing the total solar eclipse. The sun, for me, is the most dynamic object in all of astronomy. You just never know what you're going to see from day to day. A sunspot is the first thing that you'll see. It's a large area of magnetism, and it kind of chokes down the rising heat from the sun, so it appears dark on the solar disk. These active regions can grow dramatically over just a few days and become something absolutely fantastic to observe. To observe the sun, you need a small telescope. The smaller the better, because you're not trying to capture too much light or heat. You then need to fit a solar filter, which you can buy. Mylar gives you a kind of silvery sun. A glass solar filter will give you kind of a yellowy one. But if you then have a special filter, this hydrogen alpha filter, where you can see the sun's atmosphere, then you can see a churning mass of activity. Sometimes you can get prominences, which are these eruptions of plasma, and sometimes they're coming out in huge fountains and they form vast moving loops. So whilst you're waiting by your telescope for the sky to darken, do some astronomy. Observe our nearest star.
Meteor astronomy is great for amateurs because you can do whatever you like. You can make it as simple or as complicated as you like. You can either indulge in simple visual observing with your deck chair, your clipboard, doing visual observations, which are still of great value. You can use your DSLR, as Pete Lawrence did here, to produce lovely images of meteor events. And you can join in the new program of video meteor observations, where people all over the country are setting up automated cameras to record meteors on video. And there's some great science that can be done on that, but it's also great fun.
I think with Jupiter, the real challenge is its very fast rotation. In ways, it's perhaps an easier target than Mars is because of its large angular size. You can still get good Jupiter images even when the seeing conditions aren't especially ideal.
Jupiter is the largest of the planets, and it's a good model for the sort of planets that are now being discovered around other stars as well. It's a gas giant. Everything you see on the surface is clouds. And the main thing that you see with a small telescope is the dark belts and the bright zones. And these are all patterns of clouds of different thicknesses and different colours. Even with a modest telescope, you can also see some of the major weather systems on the planet, such as the Great Red Spot. Another thing that you can see with a modest telescope is the planet's 4 great moons. And in this video, for instance, you see Europa just passing in front of the planet, followed by its shadow.
With Mars, the challenge is it's often at quite a small angular diameter, so you really do need both very good seeing conditions, and you also need to make sure that your telescope is perfectly collimated to get the absolute maximum out of the telescope. Because Mars is such a small target, also you need quite a large aperture to start resolving fine detail on its surface. It's a very, very different planet to Jupiter, not only in its geology, but also in its appearance to us and the kind of techniques we employ to photograph it. With Mars, you can get very starkly different views from one filter to another. A red filter really emphasises those dark surface features that are so famous, such as Syrtis Major, while a blue filter almost wipes those features out, and all you can see are the clouds and hazes in the Martian atmosphere. I think the most crucial step really is the capturing of the raw data. It's about that initial step where the images are make or break. You're never going to get very sharp, clear images without very steady seeing conditions. So it's only on those rare, very good nights that you can capture very sharp images. I think perhaps I suffer from obsessive-compulsive disorder. You do have to be obsessive about every little step in the process. You need to try and refine and perfect, such as making sure the telescope's cooled down properly. You're constantly focusing and refocusing, even in the course of one imaging session.
In ancient times, comets used to be considered as messages from the gods. But we now know that they're actually deep frozen snowballs that were formed at the time the solar system was formed, about 4.5 to 5 billion years ago, and which, when they fall into the sun, they emit dust and gas as they warm up that gives us these beautiful objects in our skies that have tails and comas. And we're very interested in understanding what comets are made of because they contain that very early material from early in the solar system. Now, amateurs can take excellent pictures of comets, and this particular picture was taken by Martin Mobley. It was taken using a remote telescope. It wasn't taken from a telescope in the UK, but one of the things that amateurs can do these days is they can log on over the internet to use telescopes in really dark sites. This particular comet, Comet Jacques, called C2014E2 in its real designation, and as you can see here, it's got some really impressive features. It's got a nice gas tail, a dust tail and a bright coma. So I'm hoping that hopefully in the next year or two we'll get a really nice bright comet we can see from the UK, but in the meantime there are always reasonable comets around that we can image, and particularly using remote telescopes get nice images like this one.
The deep sky appeals to me because of the huge varieties of objects to be seen, from places where stars are being born, their dying embers, to distant galaxies at the ends of the universe. You can do deep sky observing at many levels, visual observing with just a basic telescope, and you can get really good images with a digital SLR camera. I have a particular interest in globular clusters, and this is an image of the globular cluster NGC 6752 in the southern constellation of Pavo. Ian Sharp took it using a remote-controlled telescope in Australia. It's amazing to see these hundreds of thousands of stars, most of which formed in the early days of the creation of our galaxy.
So I've recently been lucky enough to go to the island of La Palma, where there is a big professional observatory. And one of the reasons it's there is that the skies in that observatory are absolutely fantastic. And the picture you're seeing here is a picture of the Lagoon Nebula. This is in Sagittarius. It's a long way south, very difficult to get from the UK, but from La Palma you get a fantastic view. This is a picture taken with a normal DSLR camera. And one of the things that's really interesting in this nebula is there are things called Bok globules. You can see them in this picture as small black patches on the nebulosity. And these are protoplanetary nebulae, so these are where new solar systems are being formed. So amateurs with small telescopes can take pictures of new solar systems.
The BAA encompasses every aspect of astronomy, observing all the different kinds of wonderful objects that we see in the night sky, and with the sun, of course, also the daytime sky as well. If you join us, you'll become part not only of a great tradition, but a great group of people enjoying astronomy, trying to enthuse others about why it's a great hobby, and become part of that team looking at the night sky. The BAA holds regular meetings and workshops around the country, so why don't you come along to one of the meetings, meet other members, and clear skies for 2015.